아마도 운명들은 시간이 바뀌었다는 걸 까먹었을 수도 있으니까 일단 시작해보자. 이번 주에는 숙제 괜찮았어?
맨 마지막 것들 거의 다 이해가.
아 진짜? 맨 마지막 것들? 맨 마지막에 그 identifying transformations? 아니면 scaling functions horizontally?
Scaling functions horizontally.
horizontally. 오케이. 해보자 그럼. 처음 것부터 shifting functions. Shifting functions. Okay. So we're doing translations first. The blue graph y equals g of x is a transformation of the red graph. So we have a graph that looks like this and another red graph that looks like this, right? And we want to write a formula for the function g of x. So for this function in terms of the function f of x. So which one, you guys wanna, since there's two of you guys, do you wanna say the answer together? Or what did you both get for this one?
Is it y equals absolute value x plus 4, the
X
absolute
plus
value
4
thingy, and minus 1?
minus 1, okay. So I guess I didn't really explain this one, but when it says write a formula of g of x in terms of function f of x, that means that in our answer, there has to be a f of x in it as well. What does that mean? Well, we know what f of x is, right? It's some function. Well, we know what the function is by looking at the graph. It's what, 3 across and 2 up, but that's not important. All we want to know is how much farther away g of x is. So if you look at f of x, g of x is how much lower than f of x? 7 units down, right? If you count 1, 2, 3, 4, 5, 6, 7, 7 units down. So we can put a minus 7 there. And how many units across to the left? 1, 2, 3, 4, 4 units to the left. And if it's to the left, we put it on the x and put a positive 4. F of x minus 4. Just like that, g of x, that's g of x. Does that make sense? So we're using f of x to write g of x. But yeah, I only put one of those types of problems for each one. Let's move on to the second one. The graph of y equals f of x is shown below. It says draw the graph of y equals f of x plus 3 minus 5. Okay. 이건 예지가 해볼래? 아, 이건 어떻게 하지? I'll do this one, never mind. So f of x is this. We don't know what it is yet. We know that this point is 6, 4. We don't really know. I mean, we can figure out what f of x is by looking at the vertex, right? If you look at the vertex, you can find that it's x minus 4 plus 6, like that. But we don't want that, once again. We don't really care what the graph of f of x is. We just want the transformation. So all we know that is from here, it goes down 5 units. So 1, 2, 3, 4, 5 should be around here. And it goes to the left 3 units. So 1, 2, 3. So it should look something like this, where this is 1, 1. Did you guys both get that?
Yes.
Okay, nice. Let's move on. I'm guessing this section was easy, so I'm gonna totally move on to reflections. Reflections. Let's do the last 2 questions since we did the first 2 questions of this one. Actually, let's do this one where it says functions f, solid, and g are graphed below. F is defined as this really complicated function, -2 log 2 x plus 1 plus 3. What is the equation of g? Well, 민혁이가 이거 해볼래? 이 문제?
이거 g of x equal -2 log 이거 어떻게 읽었죠? log 2
log base 2, okay.
base 2 parenthesis -x plus 1 parenthesis and plus 3.
Plus 3, yeah. So since it's reflecting across the y-axis, all we need to do is add a negative to the x. So that should be correct. Let's do scaling functions vertically. Let's move straight on, since I think this section is easy as well. Scaling functions vertically. So this is where it gets a little hard. Functions f and g are graphed below. What is the equation of g in terms of f? So we have one function. I'm going to try to draw it well, since it's input, and another function, g. So the dotted line is function g. And we're asked, what is the equation of g in terms of f? 설리나, 이거 풀었어? 못 풀었나? 예지야, 그럼 너가 이거 해볼래?
저 이거 이해가 잘 안 갔어요.
아, 이해가 안 갔어? Okay.
네.
So let's look at this. Functions f is a normal absolute value function, because if you look at it, the slope of the graph is 1 and it's -1 here. It goes in a straight line, but in this case, functions g of x, the slope of the line is what? How do you say this? It's what do vertically, I forgot it. Shrinked, yeah, vertically shrinked, yeah. So what does that mean? Well, remember we said that if it's vertically shrinked, vertically, a has to be less than 1. I mean, greater than 1. A has, no, less than 1, less than 1. Okay, a has to be less than 1, which means that what we multiply to f of x, what we multiply to f of x has to be less than 1. So far, we know that, but how do we know what to multiply to, right? If we look at the graph, we can see that, actually, I didn't really draw this well, but you can see that one of the points is 3, 1, which means that there's a 1, 2, 3 factor of 3, right? It decreased by 3. How do I explain? So when it was initially 1, 1, that point got shrunk or stretched to this way. Actually, I should say shrunk, vertically shrunk this way, so that this point got moved all the way this point, to 3, 1, which is 3 times the amount of where it was supposed to be. The y-axis didn't change, right? So if it's 3 times the amount, then it should be 1/3, right? So when you look for vertical shrinks and vertical stretches, you look at specific points to figure out how much it shrunk or stretched by. Let's try another one. Let's try functions f solid and g dashed are graphed below. Function f is defined as f of x is 2 log 3x plus 6. What is the equation of g? So you can see from the graph that g is much lower, like that. You have a 0.16 here, another 0.12. Okay. Since we have 2 points, what did you get for this? 하늘아, 이거 풀었어? Can you tell me what you got for this? Or I guess not. 그럼 민혁아, 이거 풀었어?
이거 솔직히 풀진 않았는데 그냥 약간 답이 g of x equal 2 log base of 3 그리고 x parenthesis x parenthesis 그리고 plus 2 이렇게 될 것 같은데.
Okay, that's very good. You're almost there, but when we vertically shrink or stretch something, then we multiply the coefficient to the whole function, right? So our a has to multiply to all of g of x, which means that you got the factor right. It went to 62, so it decreased by a factor of 1/3, right? So when we multiply 1/3 to the whole function, it not only goes to 6, but we also have to multiply this beginning shit too. It should be 6/3, which is equal to 2 log base 3 of x plus 2, like that. Make sense? Let's try. Let's try one more. It says the graph of f of x minus 3, f of x equals x plus 3 minus 3 is below. Draw the graph of g of x equals 3x plus 3 minus 9. Okay. So we're given a graph this time with 3 units to the left and 3 units down, just like that. So it's here. And absolute value, like that. And it says that the graph of g of x, which is a translation, is 3 absolute value x plus 3 minus 9. So we can tell that g of x is 3 times f of x, right? Because f of x is a normal absolute value function, and when it multiplied by 3, everything increased by 3. So this became coefficient 3, and -3 became -9. So we can tell that the vertical stretch is by a factor of 3. So what do we do? Well, we have a point 3, -3. And all we have to do is increase this by a factor of 3 too, right? So when the slope is usually 1 to 1, so for every 1 to the left, it increases by 1. We do 1 to 3 instead, 1, 2, 3. So our point is there, and we do 1 to the right, 1, 2, 3. That was badly done, but your graph is much more tilted up with a slope of 3 this time, since it's by a factor of 3, where it was originally a factor of 1. Let's do the last question here. It says functions f and g dashed are graphed below. f is defined as f of x equals 2 cube root x plus 8 plus 2. What is the equation of g? Okay. Was anyone able to solve this one? Or nobody? Okay. Well, if nobody was able to solve this, I'll explain it again. What is the equation of g? So this time, it's a vertical shrink. We can tell because the graph got shorter and wider. So how do we know by how much, right? Well, we're given a point. This is 0, 6, and it all the way to 0, 2. 0, 6 to 0. Once again, that's by 1/3, by a factor of 1/3. You multiply 1/3 to 6, and it decreases to 2. So knowing that, all we need to do is, once again, multiply the known factor to f of x. And in that case, 1/3 times 2, 3, x plus 8 plus 1/3 is 2, right? Which means that this becomes 2/3 to 3 cube root x plus 8 plus 2/3. So that's our final answer. Let's move on to the hardest part of the homework, I guess, where we do horizontal shrinks and stretches. Horizontal shrinks and stretches. Functions f and g are graphed below. What is the equation of g in terms of f? Okay. So we're given two functions, that function and that function. And we know that by looking at the graph, the point is 4, 3 for this graph and 2, 3 for this graph, okay? So this time it's a horizontal shrink or stretch, right? So horizontal shrink or stretches, the x value changes, not the y value. In the other case, the y value shifted up or down. And we looked at the y value to see how much the factor increased by. But now this time it's the x value, right? So f of x, just by looking at this, it became from 4 and it became 2, right? So what does that mean? Well, it's by a factor of half, right? And if it's a horizontal, if it's moving that way, that means it's a horizontal, what is this? Shrink. Yeah, it's a horizontal shrink. So we only apply it to the x portion since it's a horizontal shrink. So if we have f of x, we only multiply it to f of x. So it's f half of x, just like that. Okay. Let's do the next question. Functions f solid and g dashed are graphed below. F is defined as f of x equals 2 to the power of x minus 2. And what is the graph of g? There's a graph. That's another graph. 3, 6. We know that point. That's 0.66. Okay. How should we approach this problem? Let's see. Once again, we look at the x coordinate, and it changed from 3 to 6. It increased this time by a factor of 2, right? We multiplied 2. So once again, we know that this is a horizontal stretch this time, since it's moving wider, and it's getting wider. So since it's a horizontal stretch, we only do it to the x. We only multiply it to the x, right? So if f of x is 2x minus 2, we only multiply it to the x. So g of x, my bad, g of x is going to be 2 multiplied by 2x minus 2, which is the same thing as 4x minus 2. So if you also have that, it's the same thing. Any confusion so far on this portion, horizontal shrinks or stretches? You guys all get it?
I kind of get it now.
Me too.
Okay, kind of get it. Okay, let's do one more question from this then. Let's see. I don't want to do the drawing question. Let's do function g is defined as what? G of x is f of 2 of x. Okay. What is the equation of g? Okay. So we have the function f drawn. Something like that. We know that this point is 4, negative 4. So this time it's not g in terms of f, so we need to know what function f is. In this case, the point here, it's increasing only by 2, yeah. So this is a normal x squared function. So f of x is gonna equal x plus 4 squared minus 4, right? Plus 4 because it moved to the right 4 units. This is 4 units, and minus 4 because it went down 4 units. That's where it is. Okay. Now let's look for g of x. G of x is defined as f of 2 of x. So all we have to do is plug in 2 of x for every x we see here. So instead of x plus 4, it's going to be 2x plus 4 squared minus 4. That's all that is to it. And g of x, if it's 2 of x, that means it's going to look something like this, right? Since a is greater than 1. Okay, let's move on to identifying transformations. This is a multiple choice part. So what did you guys get for number 1, functions, where it says functions f and g, a graph below? What is the equation of g in terms of f? And we're given this type of graph. This graph and this graph. Anyone? A, B, C, or D? Just any answer.
Is it D?
D?
D.
D? Okay, so 2 votes for D. Let's look at this. This is function f of x, and this is function g of x, right? And we know that g of x is what, 3 units lower than f of x, okay? So then f of x. So what do we have to do? Since it's 3 units lower, it's moving up or down, right? So it must be a vertical translation. And if it's vertical, we multiply it to the whole function, right? So g of x is f of x minus 3 to show that it goes down, but to the whole function, not to just x, only to the whole function. And if g of x is f of x minus 3, then that must be c. If you do d, that means it's moving left or right. So x minus 3 inside the parentheses would mean that the graph moves to the right 3 units. 1, 2, 3 units, like that, instead of moving down. What about the next one? What did you guys get? Anyone? A, B, C, or D?
I couldn't really do this one.
Okay. Let's try this one. Oh, that's so it's like that, something like that. So we can kind of tell, or we can tell that the graph is scrunched up like this way, right? Or we can also say that it's like pulled this way, right? So that must mean it's either going to be a vertical stretch because stretched that way, or a horizontal shrink because it's shrunk that way, right? How can we tell? Well,
Points on x.
Points on x. Okay, very good job. So this is kind of hard to tell, but this point here actually is not on 0, 0. And these points intercept, but they don't move left or right. The dashed function stays with, what do you call it? The original function, right? It doesn't move left or right. But this portion, it does move up or down, which means that if it doesn't move left or right, but it does move up or down, it must be a vertical stretch. Correct, by looking at the x points. So we determined that it's a vertical stretch. So we can rule out B and D, right? B and D, they multiply to only the x, which only horizontal stretches or shrinkage can do. So B or D is wrong. So that leaves A or C. To be a vertical stretch, we said that A has to be greater than 1, which leaves only A to be correct, where it says 2 is f of x, 2 times f of x. This one is half times f of x, and half is less than 1, so it would be a vertical shrink. So A is the correct answer. Any last questions? No questions? Okay. That's it for the homework then. And we are going to do our lesson. So today we're going to do equations, rational equations. So in other words, we're just solving for x, solving for x. The first type of equation we're going to do are called rational equations, where we use cross multiplication to solve for x. Do you guys know what cross multiplication is? Or have you guys heard of this term?
I heard of it.
You've heard of it? Nice. So cross multiplication is a really valuable tool to learn in math. So let's do an example question. Let's try like 2x plus 5 over x equals 2 over 3. Okay, so we're given two fractions. This part equals this part. And how do we solve for this? Well, our first step is going to be cross multiplication. For those of you who do not know what cross multiplication is, you can multiply the numerator of this fraction to the denominator of this fraction, and multiply the numerator of this fraction to the denominator of this fraction to get a new equation. So let's try that. Let's try. The order doesn't really matter. Let's do 2x plus 5 times 3, right? Multiplied by 3 is going to be equal to this. So 2 times x. Okay? And now this is much easier to solve, right, than this weird fraction thing. So now that we have it in this form, all we have to do is simplify. 3 distributes into the fraction, so that leaves 6x plus 15 equals 2 times x is just going to be 2x. 2x moves to the other side, leaving 4x. 15 can also move to the other side, equals negative 15. So x equals negative 15 over 4. Okay? That's to introduce cross multiplication. But some cases we're going to have a bit of a harder problem, right? Let's try this example. 15 over x plus 4, x plus 2 over x plus 4. Okay. Let's start with cross multiplication. One tip that I recommend while doing cross multiplication, some students like to do it, or some people like to do it, is they multiply everything first. So we're multiplying this and this and this and this together and this together, right? But before they do that, they simplify this. So they change this to x squared plus 4x, and then they start the cross multiplication. But when you start cross multiplication, it's actually better if it's in factored form, like that. You'll see why, because let's try the example first. 15 times x plus 4 is going to be equal to x times x plus 4 times x plus 2, right? You see here, we have an x plus 4 here and an x plus 4 here. We can cross those out, right? They're the same thing. If we divide by x plus 4 on both sides, they will cross out. That's what I basically did. So we can cross these out, leaving 15 equals x to the x plus 2. And then we can simplify this. So let's simplify this really quick. X times x is x squared plus 2x. And I'm going to move 15 to the other side, equals 0. We have a trinomial here, so we can just factor this. If we factor this like that, x squared is our first term. So x times x must equal x squared. If we look at our constant, what makes negative 15? Well, negative 5 and 3 does. 5 and negative 3 does. But we want, remember, if we add these together, we want it to equal our middle term, which is positive 2. Negative 3 plus 3 is going to be negative 2. We don't want that. 5 negative 3 is going to be 2, right? So we're looking for this number. So x plus 5 and x minus 3. We used these two digits. Now that we have that, we set it equal to 0, and we solve for x. X plus 5 equals 0, and x minus 3 equals 0. So x plus 5 equals 0, move negative 5 to the other side, meaning that x equals negative 5. Same here, we move negative 3 to the other side, x equals 3. So we're left with two solutions. Nice. Any questions so far? No questions? Okay. Okay. So the next thing we're going to cover is inverses of functions. Inverses of functions are, they're a useful tool to know. I find them confusing even to this day. So don't worry if it's hard for you. At first, it seems easy, but if you get into complicated math and you start working with inverses, it can get really complicated. So let's say we have a function f of x. F of x equals 4 minus x over x plus 2. Okay, so we have a function here. And our question is, what is the inverse of this function? What is the inverse? Well, what is the inverse, right? What is the inverse? Well, inverse, as you might sound, is the opposite, like the total opposite, inside out of the function. So how we find something inside out is we change x and y in place, okay? So if we want the total opposite of this, we can rewrite that as y equals 4 minus x over x plus 2. For every y we see, we just write x equals. So we change the variables. We change the variables. So 4 minus y, right? Not 4 minus x, and y plus 2. Y plus 2. So we have a new equation, and that is the inverse of the equation, okay, of this equation. That's the inverse. But once again, with equations, we don't want it in x equals something. We want it y equals something. So all we have to do is just rewrite this. So I can multiply y plus 2 on the sides. If I do that, then it simplifies to this. And I'll distribute the x like that, leaving xy plus 2x equals 4 minus y. And I'm trying to solve for y, right? So I isolate y to one side, xy, I'll move y to this side, positive y, and I'll move 2x to the other side, negative 2x, just like that. So that y is on one side. To get y, I can factor a y out. Factoring a y out leaves x plus 1 over 4 minus 2x, and divide x plus 1 on both sides. Plus 1 on both sides, leave y equals 4 minus 2x over x plus 1. So that is our function that's our inverse function. And we write inverse functions not as y equals something, but f negative 1x equals 4 minus 2x. To show that it's an inverse of this function of f of x. This was f of x previously. This negative 1, it doesn't really mean anything. It just signifies that it's an inverse function. It's not like to the power of negative 1. Yeah. Any questions on inverses? No questions? Okay, let's move on. We're gonna talk about square root next. Square roots. Square roots, it's pretty self-explanatory. Let's say we have a function like 6w equals 3. Okay. And we're told to solve for w. Well, remember we said a square root is the same as half to the power of half, right? So to get rid of this square root, we can actually multiply or raise the power of 2 to both sides. like that, so that this cancels out to be 1, okay? And that equals 9, right? So if we raise both sides to the power of 2, then this becomes just 12 minus 6w. Everything to the first power is the same as nothing. So equals 3 squared is 9. We wrote that, and all we have to do is solve for w now. We move to the other side, having -3. And -6, dividing -6 on both sides leaves half. Let's try something a bit more complicated. Let's try. Let's try. Yeah, actually, let's try this. Let's say z squared minus 8 minus square root of 6z minus 17. Okay, so in this case, equals 0, sorry. In this case, we have 2 radicals on one side. So when we solve a problem where we have 2 radicals, we don't want that. We want it on separate sides. We want this on one side and this on one side. Well, how do we do that? Well, we just add this whole thing, right? If we add 6z minus 17 on both sides, so I add 6z minus 17 on this side as well, this cancels out to be 0, and we're left with a 6z minus 17 on this side. Okay? Well, how do we get rid of the radicals now, since we're trying to solve for z? Well, we raise it to power of 2, right? I'll just do this because it's simpler. And this whole thing will cancel out then. This thing will also cancel out, leaving z squared minus 8 equals 6z minus 17. Now we just simplify. Z squared, 6z, moving it to the other side will equal negative 6z. Negative 17, moving it to the other side will bring positive 17. Minus 8 is going to be positive 9. Yeah, positive 9 equals 0. We're left with a trinomial. Let's factor that. Our first terms are going to be z. Let's look at our constant, our last term. 9 is going to be, what, either 3 times 3, negative 3 times 3. Negative 3 times 3, if we add those together, negative 3 plus negative 3 is going to be negative 6, which is what we're looking for, since that's our middle term. So we can put negative 3 in those places. And z is going to equal 3, just 3. And that's our answer. Any questions on square roots so far? No questions? Okay. Then we're going to talk about the most important part of this lesson, which is extraneous solutions. Anyone heard of this? Extraneous solutions. Does anyone know what these are?
I don't know.
No? Okay. Well, extraneous solutions are not solutions, okay? So, all we did throughout this lesson, we like solved, and we found like x equals something or w or something, right? But extraneous solutions are solutions that act like solutions, but are not actually solutions. So when we're solving, and let's say we get x equals 3, but an extraneous solution is x equals 3 is not actually a solution. But how do we find out if they're actually solutions? If x equals 3 is actually a solution, or if it's not a solution, right? Well, there are going to be two cases where there can be extraneous solutions. When you have a radical sign like this, and you raise it to a power so that you cancel it out, there can be an extraneous solution. I'm not saying there always will be, but there can be. That's one instance. And another instance is if we have a fraction like that, and a variable is underneath like that. A variable is underneath the fraction. So it's in the denominator place. In that case, there can also be an extraneous solution. Let's talk about the second case first, because this is where you usually learn about extraneous solutions. So 1x minus 2 plus 1x plus 2, 4x minus 2, x minus. Okay, let's say we have this problem and we're trying to solve for x. What's our first step? Well, our first step is to make sure that they all have the same denominators. We can't cross multiply here because we have two terms here. 1, 2, right? We have two terms. So we can't cross multiply. So we approach it like it's any normal addition fraction. We want to make the denominators the same and add. So let's make the denominators the same. X minus 2, our common denominator is going to be this. So to get that, we multiply x plus 2 on the top and bottom for this. So this becomes x plus 2. So I multiplied this and this, right? And for this fraction, well, we multiply x minus 2 on both sides, on top and bottom, x minus 2, like that. And we don't really have to change this. Just like that. And if we add the numerators, it becomes 2x, just 2x, and x minus 2, x plus 2 equals 4, x plus 2, x minus 2. Like that, okay? And now we can cancel out the denominators because if we multiply x minus 2 and x plus 2 on the same side like that, blah, blah, blah. If we multiply these two fractions on the same side, then these will cancel out. So we can cancel out the denominators, leaving 2x equals 4. 2x equals 4. If we divide both on 2 by both sides, we're left with x equals 2. But our first question, remember, we had a case where the variable was underneath. So the variable was in the denominator. So that means that this can be an extraneous solution. Let's check if it is, okay? So how you check for solutions is you plug it back in the graph. You plug it back in the equation to see if the equation works. So if we plug it back in, we're left with 1 equals, x equals 2, right? So 2 minus 2 plus 1 equals 2 plus 2 equals 4, 2 plus 2, and 2 minus 2. Let's see, does this make sense? From the very first point, it cannot make sense because 1, 2 plus 2 is 0, okay? 1 divided by 0, is that possible? Well, that's not possible, right? If you plug that in your calculator, you're gonna get math error, not syntax error. You're gonna get math error. It's gonna show it as an error because you can never divide by 0. If it was 0 divided by 1, it would be 0, but it's 1 divided by 0. So you get a math error. So this is impossible, which means that x equals 2 is an extraneous solution, meaning that it is not a solution at all. So what is our solution? Well, for this question, we have no solution. So no value of x can satisfy this equation. Sometimes you're going to have multiple solutions. And from the multiple solutions, only one or two can be extraneous solutions. So you have to check for all x values. So the second case of extraneous solutions is once again with square roots. Let's try a problem. X minus 2 plus x minus 4. Square root of x minus 2. So how do we solve this? Well, we raise it to the power of 2, right? So that we can cancel out this radical, leaving x minus 2 is x minus 4 squared. One important thing you do here is that you don't distribute the squared. You don't want to write x squared minus 4 squared. That is totally wrong. You should never do that. X minus 4 squared means that x minus 4 multiplies twice by itself. So you want to expand it so that you can just FOIL it like that, inside out. If you FOIL it, you're going to get x squared front outside minus 4x, inside negative 4 times x is minus 4x. Minus 4 times minus 4 is positive 16. If you simplify that further, you get x squared minus 8x plus 16. See how it's different from if you distribute the thing. If you distributed, you would have gotten just this, or you wouldn't have actually gotten that. You would have gotten minus 16. Squared minus 16. This and this is different, right? This is correct. This is not correct. Okay, so we simplified that a little. So x minus 2 equals x squared minus 8x plus 16. And let's simplify even further. We can move x to the other side so that it's x squared minus 9x. And we can also move plus 2 to the other side. So it's positive 18 equals 0. We're left with another trinomial. Let's factor. X squared has to be x and x. Positive 18. Can we do negative 6 and negative 3? Right. Negative 6 and negative 3 are going to add up to negative 9, right? Negative 6 and negative 3 equals 0. Leaving x equals 3 and 6. So we have two solutions this time. So we have to check both solutions, 3 and 6, to determine if they're extraneous solutions or not. So let's do that. X minus 2 is x minus 4. Okay, that was our original equation. So let's check it. Let's plug in 3 first. If you plug in 3, it's 3 minus 2 equals 3 minus 4. 3 minus 2 is going to be square root of 1 equal 3 minus 4 is negative 1, right? Square root of 1 is 1, so 1 equals negative 1. Well, no, that's not true. So we can already figure out that 3 is an extraneous solution. 3 is not going to be a solution. Let's check 6. X minus 2 is x minus 4. That was our original equation. 6 is going to be 6 minus 2 equals 6 minus 4. The square root of 6 minus 2 is 4. 6 minus 4 is going to be 2. Square root of 4 is the same as 2. 2 equals 2, correct, right? We know that 2 equals 2. So 6 is a normal solution. 6 is a real solution. That's what we call it. So when we write our answer, we can just write x equals 6 because we know that 3 was an extraneous solution. Any questions on that so far? No questions? Okay. I have a question. How many of you guys have a graphing calculator?
I have the calculator.
You have a graphing calculator? Okay. What about the rest of you guys? Do you have a graphing calculator? Or do you have like Desmos? Like, do you have access to Desmos? I guess you guys all do, right? Desmos. So, I guess we can cover this too. So we're gonna cover one last thing, which is solving equations graphically. So what does that mean? Is we use graphs to solve for equations. So solve for complicated equations, very hard ones. So let's say we have this, and we want to solve for x. There's no way we can like algebraically do this, like solve it by hand. There might be a way, but I have no idea what it is. So what we do is we solve it graphically. We graph this equation. So how do we graph this equation when we don't have a y, right? Well, how we do that is you separate these. So you separate these, leaving this as one equation and this as one equation. So if you graph, we rewrite this as y equals cube root of x, and this is going to be another equation, y equals absolute value of x minus 2 minus 1, right? So we can separate them into two different equations and graph them. So if we graph cube root of x, I have no idea what the cube root of x is going to be. Let's say we have this kind of graph. I have no idea. And let's graph this one. It's going to be something like this, right? If it was better drawn. Something like this, okay? So if we graph it on a calculator, this is what we're going to get. So what are our solutions then? Our solutions are every point that intersects is going to be a solution. So this point intersects and this point intersects with the other graph. Okay, so there's a button on a graphing calculator or on Desmos. You can just click the point that intersects and it will show you. And you can find the where it intersects, and it will give you a point like 1.1, 2, or like 3 and 4. I have no idea. It will give you the points that intersect, and when we're solving, we're searching for x equals something, right? So all you need is the x coordinates of that point. In this case, our solutions are going to be x equals 1.1 and 3, for example. Make sense? Does everyone know how to graph now?
Yeah.
Okay. Well, that's it for today. I'll post the homework on Classroom, and good luck on your homework.
Thank you.
Yep.
Thank you.
Thank you.
Thank you.